first of all, what is mean by partial differentiation? Right? What is mean by partial differentiation? Right? So what is mean by partial differentiation means already you studied the concept of the differentiation in our intermediate level. So differentiation tells that the derivative of the given function with respect to one independent variable. With respect to one independent variable. But whereas we are going to calculate the differentiation to the functions having more than one independent variables. More than one independent variable. So the process of finding the derivation to the given function, right, with respect to one or more variable, that is one or more independent variables, is called partial differentiation. Right? The process of finding the partial derivative to the given function with respect to one or more independent variables is called the partial differentiation. Is called the partial differentiation. So I am directly going to the important topics in the partial differentiation. So the first one is total derivative. The first one is total derivative. So this concept is very important. So that means that when we use this concept means, suppose if one function is function of another variable, but and that variable is also function of another variable. So in that situation, we can use the total derivative formula, right? So that means that suppose u is equal to f of x comma t. U is equal to f of x comma t, and x is equal to, right? So it is a function of x of t, right? So y is equal to is a function of y of phi of t psi of phi of t psi of is a function of phi of t comma psi of t. So observe that here u is a function of x comma t, and x is a function of t, y is a function of t. That means that u is indirectly a function of t. U is indirectly a function of t. So I'm going to have a doubt, sir. U is equal to f of x comma t, but we have x value and y value. We just substitute the values of x comma y by here. Then u becomes, it is a function of t. So it is also easy process. But you can apply that process in the competitive examination style. But in the theory case, theory examination point of view, we have to apply the concept of the total derivative. That is also correct, no problem at all. But it is better to apply the partial differentiation concept, right? So therefore, here the total derivative, that is, observe that du, the total derivative is du. With respect to what variable means? So with respect to the that is x, that is t variable, right? So that is du by dt is equal to. Next, coming to the u. So whether u is a function of one variable or two variables. U is a function of one variable or two variables. So clearly u is a function of two variables, x comma y. So if it is a function of two variables, you can use the partial differentiation operator. Though if it is a function of one variable, you can use the general differentiation operator d by dx, right? So now u is a function of two variables, so it is dou u by dou x, and x is a function of t. So that means that x is a function of one variable, so it is dx by dt. Here I am using dou. Why? Because u is a function of two variables. If it is a function of two variables, so you can use the dou operator. If it is a function of one variable, you can use the differentiation operator. Plus, next, again u is a function of y. So that means dou u by dou y into dy by dt. Right? So you can also written as du is equal to dou u by dou x into dx plus dou u by dou y into dy. Dou u by dou y into dy. So this is called the total derivative formula. This is called the total derivative formula. So it is a very simple, but we cannot mention the specify. So it is a total derivative formula. That is, this problem is solved by the total derivative formula. We cannot specify that one. But whenever it is applicable, we can just use this formula. So because of that, here I am writing du by dt value. So this is called the total derivative formula. Next, suppose u is a function of f of x comma y comma z. Y comma z. Next, and x is a function of phi of t. y is a function of psi of t and z is a function of j of t. J of t. So in the situation, what the total derivative formula means? So same formula du by dt. So you just explain this formula to the third variable also, right? So that means that dou u by dou x into dx by dt, or you can also write like next plus dou u by dou y into dy by dt plus dou u by dou z into dz by dt. So and also you can write it as du is equal to dou u by dou x into dx plus dou u by dou y into dy plus dou u by dou z into dz. So this is the total derivative formula. This is the total derivative formula. So it is very simple. So first u is a function of two variables, but x and y are the functions of one variable. That is very important here, right? So in the situation, the total derivative of the given function u is written as du by dt. du by dt. So this is the total derivative for two variables, and this is the total derivative for three variables. So likewise, we have the another that is a definition, that is chain. That is chain. So what is the difference between partial total derivative and chain rule means? So in the total derivative, u is a function of x and y, and u is a function of, suppose z is a function of f of u comma next, and u is a function of right. So h of or phi of x comma y. Next, v is a function of psi of x comma y. So observe that here z is a function of two variables and u is a function of two variables. So that means that indirectly z is a function of x comma y. Z is a function of x comma y, right? So where right, the partial differentiation of the independent variable z with respect to x is defined as, so with respect to these variables we have to find the differentiation, right? Dou z by dou x is equal to, next, dou u by dou f by dou u. Next, u is a function of, so u is a function of two variables, so that here you will use the right, so partial derivative operator. Next, plus dou f by dou v into dou u by dou v by dou x. So observe that. So here dou z by dou x, that is equal to dou f by, so or you can also use it as dou z by dou u, no problem. In place of f, you can also use dou u, right? So this is also dou u by dou v into dou v by dou x, right? So that means that dou z by dou u. Next, so that is why, because here z is a function of two variables, so that I am using dou. Next, coming to the u is also a function of two variables, but in the previous case we are using d. D means why? Because x is a function of one variable. So simply dou z by dou x is equal to dou z by dou u. Next, u is a function of x and y. So dou u by dou x plus dou u by dou z by dou v. Next, into dou v by dou x. So this is nothing but dou z by dou x. Similarly, dou z by dou y. So what happened? Dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou y. So these are the chain rule formulas. But in the case of the total derivative, we have only one formula. Why we have only one formula means it is a function of one variable. That means that first u is a function of x comma y, and x comma y are the functions of one variable t. So because of that reason, we have only one total derivative formula. But the chain rule formulas are depends upon the independent variables. Clearly here, z is a function of u comma v. Next, and u is a function of x comma y, and v is a function of x comma y. So therefore, dou z by dou x is equal to, right? So dou z by dou u into is the function of x plus dou z by dou v into dou v by dou x. So similarly, it's a function of two variables, so that there exists dou z by dou y also. Dou z by dou y means just v plus x by y, just v plus x by y. So these are called the chain rule formulas, right? So is it clear to everyone? So first one is the total derivative and second one is the chain rule. So is it clear, ma? Yes?
Yes, sir.
Yeah. So now based on these formulas, we are going to discuss about the one problem. So that is also one of the very very important problems, right? So write down that formula problem. Right. If u is equal to if u is equal to if u is equal to log of x cube plus y cube plus z cube minus 3xyz, then show that then show that then show that right? Then show that dou by dou x plus dou by dou x plus dou by dou y plus dou by dou z whole square into u is equal to whole square into u is equal to whole square into u is equal to minus 9 by x plus z whole square x plus y plus z whole square. So this is one of the very very important problem. Minus 9 by x plus y plus z whole square x plus y plus z whole square. So here given that u is equal to log of x cube plus y cube plus z cube minus 3xyz. So we have to show that this value is nothing but minus 9 by x plus y plus z whole square. Right? So someone solved that by expanding this one by using the formula a plus b plus c whole square. But it is also very good, but it takes time. So that we can solve that we can solve this one in a simple manner, right? So that is, so consider dou by dou x plus dou by dou y plus dou by dou z whole square into u. So I can write it as, so it is dou by dou x plus dou by dou y plus dou by dou z. Next into one na. So dou by dou x plus dou by dou y plus dou by dou z into u. And just expand this square as x into x. That is x square as x into x form. So now we have to multiply this one, right? So that means that dou by dou x plus dou by dou y plus dou by dou z into dou u by dou x plus dou u by dou y plus dou u by dou z. Now first we have to simplify the values of dou u by dou x and dou u by dou y and dou u by dou z. Then after that we have to substitute these sum value in this one. Then it becomes u for this one. It becomes the value of dou u by dou x plus dou u by dou y plus dou u by dou z becomes u for this one. So then after that finally you will get the required solution, right? So that is the process. Now calculate the dou u by dou x. That is dou by dou x of log of, right, x cube plus y cube plus z cube minus 3xy, right? So what the first what that is the derivative of log x. It is
1 by x.
1 by x cube plus y cube plus z cube minus 3xyz. Next, dou by dou x of this value. So dou by dou x of this one, right? So x cube plus y cube plus z cube minus 3xyz. So simplify this one. That is equal to dou by dou x of x cube. That is 3x square. Here we are doing the partial differentiation. So that means that, so with respect to what variable you are doing the partial differentiation, you have to concentrate on that variable and create the other variables that is other than the independent variables as a constant. So here the derivative of y cube with respect to x partially is 0. So it is also 0. What is the required one? Minus 3yz minus 3yz by x cube plus y cube plus z cube minus 3xyz. So this is the value of dou u by dou x. Dou u by dou x. So similarly. So please tell me the value of dou u by dou y. So likewise, don't calculate. So similarly, you can write the value of dou u by dou y. What is the value? Anyone?
Y square minus 3x z by x cube
Here
plus
just
y cube
like
plus z
3xz.
square.
So observe that here we are differentiating with respect to x. So we are getting x square. Similarly here y square. But here it is independent of x. So that it is also independent of y. So denominator is same. X cube plus y cube plus z cube minus 3xyz minus 3xyz. So call it as equation number 1. Call it as equation number 1. Right? For our simplicity purpose, so call it as equation number 1. Right. So similarly, what the value of dou u by dou z?
1 by x cube plus y cube plus z cube minus 3xyz of 3z square minus 3x.
Yes, very good. Right. So now we are calculating all the values, right? So now what the next step is? Calculate the dou u by dou x plus dou u by dou y plus dou u by dou z, right? So now dou u by dou x plus dou u by dou y plus dou u by dou z. So this is equal to. So denominator is same. So LCM is x cube plus y cube plus z cube minus 3xy. What the numerator? So 3x square plus 3y square plus 3z square minus 3xy minus 3yz minus 3zx. So that is right. 3 into x square plus y square plus z square minus xy minus yz minus zx by x cube plus y cube plus z cube minus 3xy. But we are very well known formula, right? We have that is what the formula? What the formula means? X cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into, right? So what the formula? X square plus y square plus z square minus xy minus yz minus z. So the denominator value is nothing but the product of x plus y plus z and x square plus y square plus z square minus xy minus yz minus z. Suppose if you want any doubt, then what you have to do is you can product the two terms, then you will get the left hand side value, right? So is it clear up to this? Is it clear?
Yes, sir.
Yeah. So next, Srival is clear now.
Yes, sir.
Right. Now, so you just substitute this value here. So then you will get the value of dou u by dou x and dou u by dou y and dou u by dou y. Right. So this is dou u by dou x plus dou u by dou y plus dou u by dou z. So that is equal to, substitute this value here. Then you will get x square plus y square plus z square minus xy minus yz minus z. So here the important thing is this formula. Suppose if you have no idea about this formula, then it takes time. So that means the problem becomes complexity. So that means it becomes very lengthy. So if you know this formula, then it is a matter of 1 minute, right? So therefore, the denominator value is x plus y plus z into, right? So x square plus y square plus z square minus xy minus yz minus z, right? So this one gets cancelled. So it is nothing but 3 by x plus y plus z. 3 by x plus y. So therefore, we are simplifying the value dou u by dou x plus dou u by dou y plus dou u by dou z. Now from equation number 1, right? So dou by dou x plus dou by dou y plus dou by dou z into what the next value? This value is nothing but 3 by x plus take the outside of the value. So dou by dou x of 1 by x plus y plus. Next, plus dou by dou y of 1 by x plus y plus. Right? Next, plus dou by dou z of 1 by x plus y plus. So here we have 1 by x plus y plus z, but we are calculating the partial differentiation with respect to x. So you will create it as 1 by x. What is the value of d by dx of 1 by x?
minus 1 by x square.
minus 1 by x square.
So likewise, it is nothing but minus 1 by x plus y plus z whole square. Same formula applicable here also. So here minus 1 by x plus y plus z whole square. Here also minus 1 by x plus y plus z whole square. Right? How many terms here? So 3 terms. So you can simplify that one. Then you will get it as 3 into minus 3 by x plus y plus z whole square. X plus y plus z whole square. That is nothing but minus 9 by x plus y plus z whole square. Right? So this is equal to RHS. This is equal to RHS. Right? So which is the required problem? Which is the required problem? So the problem is simple. When it is simple means if you know the idea of x cube plus y cube plus z cube minus 3xyz formula, right? So then only you will get this value simple. So otherwise you will simplify that value, right? But it takes time. It takes time. So you can simplify in this way, right? It is one of the very important problem. So it is also given in the important questions list, right? So it is very important problem. Kirtana, is it clear now? Kirtana. Lalita, is it clear now?
Yes, sir.
Yeah, good. Harika, is it clear now? Right. So this is the problem related to the right. So for partial differentiation, partial differentiation. So next one is directly the concept. Next concept is Jacobian, right? So right. So this is also very important concept. So this is when we use this concept means in the case of the transformations. Suppose already we discussed in the multiple integrals, we are transforming the Cartesian coordinates into the polar coordinates or spherical coordinates or cylindrical coordinates. So there is a one transformed value before the dx dy dz. Sorry, dr d theta or dr d theta d phi or dr d theta dz. So whatever it may be, so that is called the Jacobian, right? So this is this is used in the case of the transformations. So that means that spherical polar to cylinder, that is Cartesian to polar or Cartesian to cylinder or Cartesian to spherical coordinates, right? So here one of the important thing is first we have to observe the what are the dependent variables and what are the independent variables. So why? Because we are calculating the partial differentiations to the with respect to the independent variables. With respect to the independent variables. So here the very important thing is, so first you have to identify the what are the dependent variables and what are the independent variables. So that is the very important thing here. So then after that the process is very easy. So for two variables, right? So that is x comma y or u comma v. So in that situation, it is nothing but it is the determinant of the 2 by 2 matrix. In the case of the three variables, it is nothing but it is nothing but the determinant of the 3 by 3 matrix, right? Only we have the three variables. Why? Because we have only three-dimensional view, right? So that is x, y, z plane. So because of that, only we have the that is only that is Jacobian of three variables, right? So first, just listen. Suppose u is a function of x comma y and v is a function of x comma y. V is a function of x comma y. So here, what are the dependent variables and what are the independent variables?
X comma y are independent variables, sir, and u comma v are dependent.
Independent variables, u comma v are the dependent variables. So the Jacobian of u comma v is denoted by j of u comma v by x comma y, right? So it is also written as dou of u comma v by dou of x comma y. So right, so it is defined as dou u by dou x. Next one, dou u by dou y. Next, u is completed. Next, dou v by dou x. Next, dou v by dou y. Dou v by dou y. So this is called the Jacobian of the dependent variables u comma v with respect to the x comma y. So simply it is called Jacobian of u comma v. So it is nothing but see, that is ad minus bc. So that is dou u by dou x into dou v by dou y minus dou u by dou y into dou v by dou x. So shortly it can also written as ux into vy minus uy into vx. Uy into vx. So this is called the Jacobian. So similarly, suppose x is equal to f of u comma v. Next one, y is equal to g of u comma. So here what are the dependent variables? X and y are the dependent variables and u comma v are the independent variables. But in the above example, u comma v are the dependent variables. So observe that u is depends on x and y. U is depends on x and y, and v is depends on x comma y. So therefore, here the Jacobian is denoted by x comma y by u comma v, right? And it is written as dou of x comma y by dou of u comma, right? So it is defined as dou x by dou u. So same formula, dou x by dou v. Next one, dou y by dou u. Next one, dou y by dou v. So likewise, we can expand in this. So this is the Jacobian. So in general, it is denoted by j and it is denoted by j dash. So we have the one of the important property of the Jacobian, that is j into j dash is equal to j into j dash is equal to. So when we use this property means, suppose in some functions it is not possible to separate the x and y into u comma v or u comma v into x comma y. That means that we cannot separate x purely function of u comma v or y purely function of u comma v or vice versa. So in that situation, so you can use this formula. You can use this formula. So whatever you feel easily, you can calculate the Jacobian with respect to that variables, and you can use this formula. You can also estimate the other Jacobian value, right? So that is the reciprocal of that value, Jacobian value. So by using this property, so this is the one of the very important property. So this is also applicable to the three variables also, right? So three variables means simple one. It is a function of x, y, z. V is also a function of x, y, z. So right. Next, we have one more, h into x, y, z. H into x, y, z. So the Jacobian is defined as u comma v comma w by x comma y comma z. Here also u comma v comma z by w by x comma y comma z. So it is a determinant of the 3 by 3 matrix. It is a determinant of the 3 by 3 matrix. So what is this Jacobian? So dou u by dou x. Next one, dou u by dou y, dou u by dou z. What is the next one? Dou v by dou x, dou v by dou y, dou v by dou z. What is the next one? Dou w by dou x, dou w by dou y, dou w by dou z. So this is the Jacobian for the three variables. So similarly, we can also recognize that is x is equal to f of u comma v comma w and y is equal to g of u comma v comma w. Z is equal to h of u comma v comma w. So in that situation, the Jacobian is right. So we can I denoted it as ij dash, right? And it is defined as Jacobian of x, y, z by u, v, w, right? So that is equal to, what is that man? So this is dou x by dou u, next dou x by dou v, dou x by dou z. Next one, dou y by dou u, right? Next one, dou y by dou v. Next, dou y by dou w. What is the next? Last one, dou z by dou u, dou z by dou v, dou z by dou w. So this is called the Jacobian, right? So here the important observation is, in this case, u comma v comma w are the dependent variables, but here x comma y comma z are the dependent variables, right? So that is the one of the very important that is important thing, and from this we concluded that j into j dash is equal to 1. So that is j means that is the Jacobian of u comma v, v comma w with respect to the independent variables x comma y comma z. J dash means the Jacobian of x y z with respect to the independent variables u comma v comma w. So therefore the property is the j into j dash is equal to 1. So this is the one of the important property in Jacobian, right? So this is the way of the representation of the Jacobian band, right? So the next one is, suppose u is a function of r comma s. Next, v is a function of r comma s. Next, r is a function of, right? So r is a function of x comma y, x comma y. Next, s is a function of L of x comma y. Now, in the situation, the Jacobian of u comma v by x comma y, So is defined as Jacobian of u comma v by Jacobian of r comma s into Jacobian of r comma s by Jacobian of x comma y. So right. So this is the one property. So this is the second property of the Jacobian. So that means that here u is a function of r comma s and v is a function of r comma s. Next, r is a function of x and y and s is a function of x comma y. So in that situation, the Jacobian of u comma v with respect to x comma y is denoted as, right? So Jacobian of u comma v by r comma s. Why? Because so u comma v are not directly function of x comma y, So u comma v are functions of the r comma s. So the first we have to calculate the Jacobian to the u comma v with respect to the variables r comma s. So coming to the second one, so here r comma s are the dependent variables, x comma y are the independent variables. So because of the here dou of r comma s by dou of x comma y. So this is the one of the property of the Jacobian. So is it clear to you everyone? Yes?
Yes, sir.
Yeah, right. So and one more thing is, right? So suppose that is suppose x is a function of u comma v, y is a function of u comma v, but they asked the Jacobian of u comma v by x comma y, So that means that originally x comma y are the dependent variable, but what they asked Jacobian of u comma v by Jacobian, that is x comma y. So that means that here u comma v are the dependent variables, but here u comma v are the independent variables. So what we have to do here is, first we have to change x comma y, that is the dependent variables, into independent variables. So that is, you can write it as u is equal to some f1 into f1 of x comma y, v is equal to f2 of x comma y. So this is the process. So this is solved based on the given problem. Suppose if you ask to Jacobian of x comma y by, right, u comma v. So no problem. So you can calculate the Jacobian value directly. Why? Because clearly x comma y are the dependent variables and u comma v are the independent variables. So So that means it is a correct order. But if they ask this value, if they ask you this value, then what you have to do is there are two ways. So one is first you have to calculate this value and use the property number 1, j into j dash is equal to 1. So this is nothing but j dash. This is nothing but j dash. So in that way also you can calculate the j dash value. So or else, so you can simplify u comma v in terms of the x comma y. So that means that you can change u comma v values in terms of the x comma y. So clearly you can calculate the Jacobian to the u comma v with respect to x comma y. So this is the another, right? So this is the another. So now we can solve some problems related to this. Then you will get the full clarity about this, right? So is it clear to you? And one more thing is,
Yes, sir.
suppose if the functions are implicit functions, the functions are implicit functions. So what is meant by implicit function means if we cannot separate the dependent variables and independent variables in the given function. So that means that u plus v is equal to x square plus y square. This is an implicit function. It's not possible to separate u comma v into purely function of x comma y or x comma y in terms of the u comma v. So in that situation, what you have to do is you consider it as that is f1 and you consider another one is f2. Another one is f2. So Jacobian of u comma v by x comma y is equal to Jacobian of f1 of right x comma y by Jacobian of u comma v by Jacobian of right f1 comma f2 by next one is Jacobian of f1 comma f2 by Jacobian of x comma. So here -1 whole square. Here I am taking two variables so that here it becomes -1 whole square. So this is the third property of the Jacobian. So this is used for the implicit type functions. This is used for the implicit type functions. So that means that clearly they are given two functions in the given problem. So take one as f1 and another one as f2. So therefore you have to calculate the Jacobian of this one too is -1 whole square. Suppose we have three variables, it is -1 whole cube. So right. So this is nothing but dou of u comma v by dou of x comma f1 comma f dou of f1 comma f by dou of f1 comma f2 by dou of x comma, right? Otherwise, we have reverse రాశాను this one. So reverse రాశాను. This is dou of x comma y by dou of f1 comma f. Dou of f1 comma f. So this is for implicit type functions, but it is not important one. So right. So write down the first problem. Very simple problem. X is equal to r cos theta, y is equal to r sin theta. Find Jacobian of x comma y. Jacobian of x comma y by r comma v. By r comma v. So Jacobian of x comma y by r comma theta. It is nothing but dou of x comma y by dou of r comma theta. So what the formula? So this is dou x by dou r, dou x by dou r. Next dou x by dou theta, dou y by dou r, dou y by dou theta. So is it clear now? Yes?
Yes, sir.
Yeah. So now calculate the values of dou x by dou r. What is the value of dou x by dou r?
Cos theta, sir.
Very good. Cos theta. So directly you can replace. So this is cos theta. Next, what is the value of dou x by dou theta?
Minus
Minus
r
r
sin
sin
theta.
theta.
Yeah, very good. What is the value of dou y by dou r?
Sin theta.
Sin theta.
Value of dou y by dou theta?
R cos theta.
R cos
So
theta.
calculate this one by taking the determinant of two variables, right? So this is r cos square theta plus r sin square theta. So that is nothing but r. So this is the Jacobian of x comma y by Jacobian of r comma theta. And also you can estimate the value, that is j j dash of r comma theta by x comma y. R comma theta by x comma y. What is that value?
1 by r, sir.
Yeah, 1 by 1 by. So why? Because j into j dash is equal to 1. J into j dash is equal to 1. So we can also solve that one also. So this is direct way. This is direct way. Now, if you want to calculate the j dash value, if you want to calculate the j dash value, that is j dash of r comma theta by x comma y. Right? So this is nothing but dou of r comma theta by dou of x comma y. Right? So this is nothing but dou r by dou x. Next one. Dou r by dou y, dou theta by dou x, next one, dou theta by dou y. So that means that so you can convert the variables r comma theta into x comma y. So originally x comma y are in terms of r comma theta, but here so now for this calculation here the dependent variables are r comma theta and independent variables are x comma y. So that means that you can change this one. You can change this one in terms of the that is r comma theta in terms of the x comma y. So what is x square? R square cos square theta. What is y square? R square
R
sin
square
square.
sin
R square
What is
sin
x square plus y square?
r square, sir.
R square. So that means that R square is equal to what? Right? So that means that it is a function of that is R is a function of x comma. R is a function of x comma. So which implies that 2r into dou r by dou x is equal to 2x, right? So that is dou r by dou x. Dou r by dou x is equal to x by r. Dou r by dou x is equal to x by r. So that is equal to x by what is r? What is r? Square root of x square plus y square. Similarly, we can estimate the value dou r by dou y. What is that value?
Y by r, sir.
So that is nothing but y by square root of x square plus y square. Must really is clear to you, ma? Next. Now, so we are changing r in terms of x comma y. It is very good. Now we are going to change the theta in terms of x comma y, right? So here I am taking y by x. That is r sin by r cos theta. So which implies that tan theta is equal to y by x. So that is theta is equal to tan inverse of y by x. Tan inverse of y by x. Next, what is dou theta by dou x? It is nothing but 1 by 1 plus y square by x square into dou by dou x of y by x. Right? So that is x square by x square plus y square into this is minus y by x square. So this one cancel. So that is equal to minus y by x square plus y square. So this is the value of dou theta by dou x. Next, now calculate the dou theta by dou r. Sorry, dou y. So dou theta by dou y is equal to same process. 1 by 1 plus x square by y square. Sorry, y square by x square into dou by dou y into dou by dou y of y by x. So right. So this is nothing but x square by 1 x square plus y square into this is 1 by x. Right. So 1 by x is the constant. Dou y by dou y is 1. So it is x by x square plus y square. X by x square plus y square. So you can substitute these values in the given form. That is Jacobian. Right? That is j dash of j. What is the dou?
minus y by x square plus y.
Minus y by
Yeah.
x square plus
This
y
is
square.
y by x square plus
Minus y, sir. Sir, minus y, sir.
minus y. So this is x by x square plus y square. So do the cross product. So that is it becomes x square by x square plus y square into square root of x square plus y square minus into minus. So this is y square by x square plus y square into square root of x square plus y square. So that is equal to x square plus y square by x square plus y square into square root of x square plus y square. So this one cancel. That is equal to 1 by square root of x square plus y square. In terms of r, what is r? Square root of x square plus y square. So this is 1 by r. This is 1 by r. Right? So this is the process for evaluating the j dash. Evaluating the j dash. So here the important thing is initially, right? X comma y are the dependent variables. X comma y are the dependent variables. So here what we are doing is we are changing, right? So x comma y, that is r comma theta as in terms of x comma y. In terms of x comma y. Why we are changing means, so if you want to calculate j dash, so r comma theta must be dependent variables. So because of that reason, I am changing r comma theta in terms of x comma y. So how I change it means, so by taking this, right? So x square value and y square value. So x square plus y square is r square. So clearly r square is a function of x comma y. Next one. So coming to the theta. So how I change the value of theta means I am taking y by x. So suppose if you ask, sir, I am taking x by y, no problem. It is your choice. If you take x by y, then you will get the half inverse. So, but we know we know the formula of tan inverse theta very well. So because of that reason, I am changing the value in terms of the tan value, right? So therefore, finally, I am getting the value that is 1 by r, and I prove that j into j dash is equal to 1. So based on this result, I prove that j into j dash value is 1. J into j dash value is 1. So is it clear to everyone? Yes?
Yes,
Yes,
sir.
sir.
Yeah, but the process is very easy. So first you have to observe what they are asking in the given question. So based on that observation, then you can follow. Suppose if they ask by using j dash or show that j into j dash is equal to 1. In that situation, you must calculate j dash also. Suppose if they ask to find the j dash, so in that situation you can use the value j into j dash is equal to 1, and by using that property you can also calculate the value of j. But if you ask to show that j into j dash is equal to 1, so there is no alternative way. So you must calculate the value of j as well as j dash, right? So that is the very important. Okay, is it clear, ma? So similarly, like this problem. So I will give one problem to you. Then you can solve that problem. So by using the same concept, that is also one of the important problems. So right. So x is equal to e power u cos v. Next, y is equal to e power u sin x is equal to e power u cos v, y is equal to e power u sin v. Show that j into j dash is equal to 1. Show that j into j dash is equal to 1. So you can follow this way. That is likewise this problem. You can simplify that. So show that j into j dash is equal to 1. So in the situation, you must calculate the j and j dash. So there is no alternative way. In the case of j, x and y are the dependent variables, so it is very fine, no problem with that. In the case of j dash, so there is a problem. So that means that we have to convert u comma v into x comma y. So likewise previous problem, right? So here j is nothing but dou of x comma y by dou of u comma. Next, J dash is nothing but dou of x u comma by dou of x comma. So by using this way, you can calculate the given Jacobian. That is, you can show the J dash and then you can prove J into J dash is equal to 1. J into J dash is equal to